Hi everyone, very good evening. We will start the session in like 4 5 minutes. I hope all are excited. You guys are coming on a Saturday, and we'll wait for some more time for a few more students to attend. And let this be. Saw a lot of students on LinkedIn posting regarding this internship. That excitement, let it continue till the project you complete. It will be a very smooth journey, and yeah, we will begin in like 3 4 minutes. Okay. So today's session will be same as what is being done yesterday. Those who have attended yesterday's session, they need not attend it now. It's the same thing because since the batch size is very huge, we are divided into two sessions. It's the same session, but if you want to recap or didn't understand yesterday's session very well, you can attend the session also. Okay.
And Adarsh, I have shared the WhatsApp uh, group links with you. We have eight WhatsApp groups for this project. So I have shared with you on our groups, on our teams. Please join to
Okay.
all the groups. If they have,
Okay.
and I will make you admin so that you can also answer to their queries.
Okay.
So we did kept open for everyone because there will be a miscellaneous messages sent by students.
Okay.
So here, I think next 1 minute you can start the session. Hope the recording is going on.
Yes. Yes.
Okay. Let me down my screen.
So, okay, one thing to be clear, people are confused about project for which batch I am. Can you please tell me? So, see, your projects and batches has already been properly assigned, right? This is batch two, and yesterday was batch one. So today it's general for every batch, every project. This today's session, and other sessions dates based on your project has been assigned next week, right? For each project you have chosen, the dates are there. So go align with the dates. And today's session is a common session for all the projects. It's an introduction to AI. Okay. So it's already 5 5. I will slowly start
Yeah,
my
you
session.
start the session.
Okay.
The main
Okay.
only number.
Good evening, all. Yeah. So this is a Saturday, and you guys have all come here with
Oh,
a
oh,
lot of.
one more thing, like Adarsh, again, you introduce yourself to
Yes, yes, yes.
these people because there are many newcomers are there. That's why.
Yeah, sure, sure, sure. So, good evening, all students, and my name is Adarsh. I am a master trainer in EduNet Foundation. I have an experience, 4 years experience as a data analyst and a data scientist. One working in mechanical field of this one. I have worked with predictive maintenance of machines and turbo engines. I completed my mechanical engineering in 2019, and further I switched my career to data science while working in the mechanical engineering. Companies. And right now, with the knowledge which I have an experience of 1 year of training students in the field of data science and AI. and I would like to continue it with fashion so that a lot of students come to this field of AI and data science. So, yeah, this is about me. And today's session, it's regarding an introduction to AI, artificial intelligence. A lot of students had been asking, "Sir, will you start it from the basic or something?" Guys, this is an internship, right? You're doing an internship, and it's kind of half of the work, or 60% work is from your side. You should put efforts from your side. We will teach you some of the basic concepts, but I recommend you to go back and give a little bit efforts of learning things theoretically and practically. When you do hands-on project, at that point you'll be learning things. You'll be learning for each one you do the project, each unique projects which you have chosen. When you do the project, in that point of time you'll be learning things. So let that be the way of learning. So today's session is so students who have already have an idea of data science, today's session will be like you'll have a recap of it. Those who are very new to it, I'll be introducing you to what is the artificial intelligence, what is data science, what are the roles which are there, a little bit of machine learning, and if time permits, I'll be taking you through deep learning concepts also. And what are the projects or technologies we will be learning while doing these projects? All these things will be cleared. Okay. I'll be also telling you what efforts you need to put in the theoretical side, which concepts you need to look into after this finishes, because you have 2 days. Like Sunday is there tomorrow. From your side also, do put some efforts in learning some of the concepts which I am explaining today. So let me start. I'll start with sharing my screen. Okay. Second.
Hello?
Give me 1 second, guys. Okay. I hope my screen is visible. Pawan, can you just confirm me? Pawan, can I get a confirmation if my screen is visible?
Yeah, it's visible. It's visible now.
Okay. Okay. So let's start the session, guys. It's already 5:10. We have almost like 1,000 students here. Let's start the session. So, before I start it, I know you might have a lot of doubts in your mind, curiosity in your mind. So, let's we have very short span of time, 2 hours time, 7 o'clock, right? It's better to go with a good agenda of what are we trying to learn in this 2 hours, so that you guys don't have a confusion and ask a lot of things. We'll do that, this. We will have a small agenda of what are we going to do in the session. So in this session, I'll be introducing you to what is AI, what is intelligence, what is artificial intelligence, and explaining you what is the difference between, or what does AI, machine learning, deep learning, generative AI. These terms are very common. What are these? And what is the difference between these terms which are there? How is the market when it comes to different jobs of these? Then slowly we will be looking into some good real-time examples of where artificial intelligence is used nowadays, so that it gives you a motivation of where you can apply these technologies in your real life problems. And three, we will be going through its machine learning concepts, some of the few concepts of machine learning which will be very useful for your projects also. Okay, and if time permits, I'll be taking a little bit of deep learning. Okay, so that you will have an idea just of it. But as I told, a lot of efforts from your side is also very important. Okay, let's begin. Okay, what is intelligence? In the artificial intelligence, when you say the basic one term is there, intelligence, and what does it mean? So, people, some students have doubted intelligence. When I asked one of the students before, and when I was taking a session, he said that if I get 100 out of 100, that person is intelligent. See, 100 or 100 is an evaluation technique. It's known as not a intelligence measure, right? Intelligence is the ability to learn and understand and apply knowledge and skills, where it involves reasoning, problem solving, and adapting to new situations, right? That's what we call intelligence. Um, Pawan, can you confirm if recording is happening? My side,
Uh, Recording is happening. Yes,
recording is happening, right?
I think so. It should show in your system. Recording.
Able to see.
You check once, please. Yeah, yeah, it's recording now. Recording. It's showing now in the uh, right side.
Yes, yes.
Recording is going.
Okay, great. So, that's what intelligence is. It's ability to learn, understand, and apply the knowledge and skills. Right? It involves reasoning, problem solving, and adapting to new situations. And now it's create one small example happened here itself. Yesterday, some default happened, and the recording didn't happen by chance. So, understanding that situation, I use my intelligence. Just giving you a small example. I asked my teammate whether there is recording happening or not. That small thing of adapting to new situations, that's what intelligence is. But did our machines or the artificial intelligence reach to that level? Well, we'll look into where are we. This term AI is being used a lot in this 4 years. Did we reach to that level where it can replace to humans? Did it, where are we in that journey? We will just look into it. Okay, so that's what intelligence is about. It's a combination of a lot of things. Let it be visual, musical, body, in interception, everything in all these manners. When we say that we call it that machine or person as a intelligence machine, right? So there are two levels of intelligence. One is human intelligence and artificial intelligence. So human intelligence, it means our natural ability to think, learn, and adapt, right? It includes skills like logical thinking, understanding emotions, being creative, and interacting with others. That's what human intelligence is. An example is like, imagine a student learning to play the piano. That's what comes under human intelligence. And when it comes to artificial intelligence, when machines are made to think and learn like humans, right? That's where we call artificial intelligence. AI is in that form is what you call artificial intelligence, right? And one big example is, you can see everywhere in your smartphone, Siri or Google's made is there. All these it's just small things which are there in your daily life. It comes under part of artificial intelligence. Okay, so let's just walk into the history of what are the first steps towards artificial intelligence which took place. And I hope this video is seen to everyone. Wait a minute. Okay. So I hope this video is audible and seen to you.
This is audible.
The idea of artificial intelligence can be traced back to the work of Alan Turing carried out in the Second World War. Alan Turing is widely regarded as having a highly significant role in pioneering the development of computer science and artificial intelligence. During the Second World War, Turing and colleagues created an automated machine for breaking secret codes, known as the bomb. This machine could find the solution to code-breaking problems in minutes, tasks that would have taken humans weeks to complete. The bomb could effectively do something that no human could. The bomb was a moment when it became possible to speculate on the limits of what machines could do. Turing's work on the bomb influenced his thinking on the possibilities that computing may have for the future. In 1947, during a public lecture, Turing gave what is thought to be the first mention of computer intelligence, saying, "What we want is a machine that can learn from experience." In 1950, Turing wrote a paper entitled Computer Machinery and Intelligence, where he began posing the question, can machines think? It is from this paper that the Turing test derives. Turing begins by speculating with the question, can machines think? But he then goes on to say that that's a very difficult question to answer because it's very tricky to define thinking or even how to measure thinking. So instead of attempting to answer that question, can machines think, he chose to replace the question with something he called the imitation game, where it was asked if a machine could convincingly imitate a human. This game eventually evolved into what we now think of as the Turing test.
Okay. I hope you understood what he tried to mean, where the AI thing, Turing thing came up. But if you've not understood what Turing test is, I'll make it more simple for you. So what Turing wanted to mean is when he had this question about how to term a machine as an intelligent, he did this test. This test in which to term if a machine is intelligent, and that test is known as Turing test in his name. So in simple words, what he has done is he kept a person he kept a person like this and who's constrained or there is no he's blocked from the both sides, okay, and he's isolated from the environment outside, and in one side there is a human respondent and the other side there is a machine, okay, and this person has no idea of which is a machine and which is a human. So where it is being kept, he has no idea about it. What he did, what Turing test says is that if this person asks any question or query and in this isolated environment and he gets feedback from this machine and also from this human respondent, but if he's not able to differentiate this answer, this feedback which has come, whether it is from the machine or whether it has come from the human, if he's not able to differentiate it, that means this machine is considered as an intelligent machine. So if he's not able to figure out whether it's a human or a machine which is given out, he feels that both of them who have given the response is humanly in nature. If he's not able to differentiate it, then means the machine has passed the Turing test of being an intelligent machine. That's what Turing test is. Okay, very simple. So if you look into the artificial intelligence field, where it has reached, where are we right now? Because ChatGPT, every day there is some or other innovation which is happening in this field. Where are we? When I asked one of my students before in one of the sessions, where are we in AI? He replied me that we already reached super AI. That is, the artificial intelligence robots have become more intelligent than human. But are we really in this position? To be honest, we have not reached here till now. A huge research is being done still to reach here. Or even if the research is being done, there is a lot of ethics and values which comes into place whether to reach here or not. Okay, it's still in a question mark. Where are we right now? We are right now in the narrow AI, where it's dedicated for one task, right? What ChatGPT does, you ask something, it gives you some answer, right? Or Siri asks you something, it does something. It's not going to do something on its own, right? We ask something, it gives something. So we have reached only into that stage of narrow AI. We are still developing in it. We are doing research in it. But recently you would have seen some of the robots, Sophia and Ameka being released, right? In the newspaper, you would have seen these robots. And that's the journey of reaching the general AI, where the robots are trying to perform like human. It's almost we are about to reach it. We have not reached it completely here, but we are almost in the path of this side here. And we are in the position to almost fulfill this by like in next coming years. Okay, and there is a lot of advantages and there is a lot of disadvantages in that. So we'll be just looking into one more video of where this robotic race, how robots have where it has reached in generative AI. Okay. Okay, so it's regarding Sophia versus Ameka.
Do androids dream of electric sheep? We don't know, but they look terrifying, and terrifyingly human-like, once they wake up, and that's how humanoid robot race is started. Engineered Arts, a UK-based robotics company, has created a humanoid robot named Ameka, which has everyone convinced it's a Black Mirror episode come to life. We already know Sophia humanoid robot, created by Hanson Robotics. Sophia already mesmerized people with its ability to interact with people, including celebrities like Will Smith in real time. Sophia is capable of imitating human gestures and facial expression using her facial motors. She's equipped to answer certain questions and engage in simple conversations. Cameras are embedded in Sophia's eyes, and along with computer algorithms, she's able to see things. Soon she can also able to walk. But wait a minute, Sophia got competition from Ameka. Ameka is the world's most advanced human-shaped robot, representing the forefront of human robotics technology. Ameka can express emotions like a real human. Ameka designed specifically as a platform for development into future robotics technologies. Ameka is the perfect humanoid robot platform for human-robot interaction, apart from Sophia. In future, with advancement in AI technology, these robots can do many jobs, like taking decisions in financial market, caring for people in hospitals, and they can also work in hostile environments. Maybe soon Elon Musk can send them in space to establish humanity on Mars. So here is question for you, who looks more realistic to you? Sophia or Ameka? In future both can able to walk, and can be deployed in every home. They both can interact with you, sometimes they can love you, or they can talk with you in lonely times. You can customize them the way you want. So guys, based on their intellectual ability, which humanoid robot you want to keep in your home? We are interested to hear your thoughts. Share your thoughts down in comments section, and don't forget to subscribe the channel and press the bell icon to get instant video notification. So guys.
Okay. So you watched a video and there's a question whether Sophia or Ameka will you use in your home. I would suggest it's always better to have a person in home rather a robot, right? We don't want to reach that level of having. It's better Elon Musk sends robot to Mars. Earth let humans do well things. But what artificial intelligence can do is increase our productivity, right? Let it be students' life, or let it be in the work life, or let it be in any business channels. If artificial intelligence is going to enhance our productivity or the business productivity, that's what the aim of artificial intelligence is and machine learning is about to do. Robots are, we are better than robots at any time. It will never be that the robots are going to happen, but this field is going to enhance in a very high manner in the coming years. But in this 3 slides, you read AI, you went through AI, artificial intelligence, machine learning, deep learning. What are these? But Are they correlated to each other? Why, or is it very different terms? Your project, one of the project has machine learning. I mentioned in the first orientation. One of them is about AI chatbot. Another is about deep learning. But all these are correlated or they are different. Let's clear it now. Okay, let's clear that doubt right now. So, what is artificial intelligence? AI. So, artificial intelligence, if I would say, it is, if I make this box, the complete universe, you would have heard about subsets, right? If this box, if I make, this complete box can be considered as AI, artificial intelligence, the whole universe, where it's a technique which enables machines to mimic human behavior. Or I would say also define it as building applications that can perform, like a human without human intervention. So without any human intervention, if you have built an application that can work, that can perform like what humans do, and that is what you call artificial intelligence. Example, take Netflix recommendation system. Do any human needs to do, you all would have gone seen Netflix, right? And how does Netflix work? They have a recommendation system. It recommends movies. I have my friends who literally watch for 2 3 weeks continuously Netflix because it recommends good movies based on what they watch. How does it happen? Is some human sitting there and checking, oh, this guy is watching this movie, this guy is other? No, it's the machine modeling which has been done. Some engineers have worked on a great model which automatically recommends movies to that person, right? So that's an example of artificial intelligence, Netflix recommendation system. But what is machine learning? Is machine learning very different from AI? No. Machine learning is one subset of artificial intelligence. It's a subset, it comes under the artificial intelligence. So if you've done a machine learning model, it is already inside an artificial intelligence model. Okay, so what is machine learning? But so machine learning, basically, it uses some statistical tools. It uses statistical tools and applies it on a data. It applies statistical tools on data to do certain functions like feature engineering, data visualization, and finally train a model based on some of the statistical applications. It trains a model and then it predicts. It predicts based on what training has been given. That's what machine learning is about. Okay, so machine learning, you have a data which is being given to a machine and the machine gets trained using some of the statistical tools, algorithms. It uses that. And further, after getting trained, it will try to predict of whatever another data which you give. That's what machine learning comes. And once machine learning came into phase, what happened is that it could handle certain amount of data. If their data was like 10,000, 1 lakh data, it performed very well, the data set. But once the data set became very big, you remember when Facebook, Instagram and all came up, they had huge amount of data with them, and they were like, how to handle this data now? Can machine learning models do it? What happened is that as data increased, the performance, if I see performance, the performance, machine learning model performed very well when the data increased like this. But after certain point of time, it became constant. The performance became constant as the amount of data increased. And scientists thought, now how to handle this? And scientists developed neural networks. They developed some neural networks. And they developed neural networks in which deep learning concept came. As the data increased, the performance of this model increased. In the case of deep learning, in machine learning, when it became constant, deep learning, the performance increased as the data increased. So that's how the concept of deep learning comes, where it handles through neural networks. What is neural networks? Similar to how our brain functions. So when we get an input, right? If I touch a hot tea or hot coffee, I know it's a hot coffee, and I just take out my hand, right? So that is because some of the neurons get that connections go on. Electrical connections inside in my brain goes on. It understands that there's a hot object, and I remove it. The output is to remove from my that hot coffee, right? So that level of neuron, that way of connections were made, where we created neurons, and there was input layer, hidden layers, output layers. So scientists created such layers to handle data, where training has been done using these neurons were used, and it performs, this deep learning model performs very well when the data is very huge. When you have 1 million records, 10 lakh records, it's always better to go with the deep learning method. Machine learning doesn't work very well when you have a huge number of data. So you might be thinking, students always have a doubt. I will only learn deep learning because deep learning is now everywhere used. No. When you have a small data set, when you work in startup, a small company, when you have a small data set, when you're working on a fraud risk, this one in some of the companies, you will be using still machine learning algorithms. So it's very important to learn about machine learning and then go to deep learning. Okay, so that's regarding deep learning. It's a subset of machine learning which make computation of multi-layer neural network feasible. Okay, and after which further research happened, and then from the deep learning thing we went on through NLP, right? This deep learning itself has three branches. One is artificial neural network, another one is convolutional neural network, third one is recurrent neural network, right? Convolutional neural network, it's when you have images. When you have images to be handled, we use convolutional neural network, which basically works on again on neural networks itself. When you have regression and classification type of problem, we go with artificial neural network. RNN, recurrent neural network, it is further enhanced version of ANN, in which is used mainly when you have text processing. You know, Gmail and LinkedIn and all, when you type some things, it suggests some of the words, right? It will suggest the next word, what to type, what to give. This works on the recurrent neural network, RNN. So RNN also, it can be used for forecasting. What is forecasting? For example, if I want to forecast, understand what will be the sales after certain days based on the sales history. So it will look into the past information and then give the next what will be the sales. So in these situations we'll be using RNN. What is text processing? Why do we need text processing RNN, recurrent neural networks? Because I'm writing, the man is wearing. So if I write the man is wearing, now in my Gmail, when I write it, it will suggest some word, is wearing a coat or a shirt. It suggests some of the words, right? It's based on the previous words. It will take the memory of these previous words. That's how it is able to suggest the next word. So this giving a suggestion of this next word, that works on the recurrent neural network. RNN algorithm will be used there. And further, this deep learning thing enhanced towards generative AI. Very hot topic, which is seen everywhere now. Now, recently in 3 or 4 months, you would have heard about agentic AI also, right? If you have been updating with technology, you will have heard about agentic AI also. It's recently, which is very popular. So generative AI, what is generative AI? Generative AI really simplified many of the things. What it did was, some great companies, like in a simple word, I'll just explain you in a very simple manner what generative AI does. Basically, imagine I got, tomorrow is a Sunday, and I got 20 to 30 books. 30 books I got to learn about dogs. Okay. Regarding dogs, and these 30 books I've studied, I completely learned everything about the dogs, different types of dogs, what are their breeds, everything I studied. And now if you ask me a question, I can answer that, right? I can answer what about dogs, right? Similarly, what this great big companies like Google, OpenAI, they have worked, and Facebook with Meta is being used. These big companies have worked with their architecture, the big architecture. They have created LLM models, large language modules, right? They have created large language models where it has learned from a huge amount of data from the internet, a very huge Wikipedia, textbooks, a lot of books. It has learned from it, and from this model is known as a foundation model. This foundation model, we can use this model to fine tune it for our own purpose. Now you'll be having a doubt. I have ChatGPT. You have one of the projects AI. You have one of the projects AI chatbot, health health chatbot, right? You have this project with you. So you'll be thinking, why do I need a AI health chatbot when I have a chat GPT where I can type my queries and it will give nice suggestions? The thing is, your chat GPT takes your data, it uses your data. It's not a company where it's private. It will be giving you information that your data is being used. At that point of time, when a private company like Amazon or Flipkart or your AI healthcare chatbot, when you're creating that chatbot, you should not be giving your private details, right? A company details cannot be given to an OpenAI chatbot GPT platform. You need a separate chatbot, right? Which is fine tuned for your needs, what type of answers you require, right? If you're working on a medical data set, medical chatbot, so what type of replies this chatbot has to give, you can fine tune it. You can fine tune what type of replies it has to give, and you can grade them. So that's what, based on that grading, it will learn from it and it will give better response. So even chat gpt was doing the same thing. It is using one of the libraries, OpenAI LLM platform. It is using from that platform. It has been fine tuned in such a way that it will give queries. A lot of engineers have worked on how to give the answers for different queries, and it has learned from it, and still it is learning. There will be sometimes when you use chat gpt, when you give a they'll give two response, and they'll ask you to choose which response is better. So at that point of time, the chat gpt is learning from which response is better, and that it gives better output. And that's what the concept of generative AI is about, right? I hope you have clear idea now what is AI, what is machine learning, and what is deep learning, and what is generative AI in an overview point of time. Okay, what are the definitions? So these each concept is a huge thing to study. There's a lot of things to study in it, and while doing project, you will be learning a lot of things. That's the beauty of doing projects, right? Hands-on projects. Okay, so applied AI refers to practical implementation of artificial intelligence technologies to solve specific real world problems and automate tasks. That is applied AI, what you're doing right now. And some of the real world cases, you see every field now. I'm telling you, there is no field right now where there is no AI being used. And specific highlight to the medical industries. To be said, if you every pharmaceutical industry and medical industry requires a data scientist, requires a artificial intelligence, because they have a huge amount of data, and they require data to create better interpretations, business analytics, and understand about the disease, everything. And recently, look at this. Your X-ray, there is an X-ray image available, right? And if I train the model based on different lot of data from some of the hospitals of X-rays, and after training it, now if I show some X-ray, what if my model can detect if there is a disease or not, right? That's the advantage. Machines, one of the great advantages of machines, if it's a well-trained model and able to detect something which might be the doctor is not able to detect it, because humans can make error, right? And if machine is able to detect it, it's going to save a life of a person, right? So that's one of the greatest application which you can see. And another one great application which I really worked in was predictive maintenance. Predictive maintenance. I would like to give you a little bit hint about it. So You all have, you would have seen an automobile. You might have an automobile in your home, might be a car, might be a bus, anything, right? A car or a bike, sorry, but not a bus, a car or a bike. And this personal vehicle, you would have tried to give it for a service in every 6 months. You either you give, or the company person calls you and tells you, please get your vehicle in time, and we have to service it, right? And this is known as preventive maintenance. What is preventive maintenance? That is, you're trying to maintain your bike or a machine before something happens. You're giving a preventive maintenance, that checking if everything is proper, and doing it a complete this one based on how many kilometers you have run, or how much age it has reached. But what happens? Some of us would have not ride the bike a lot. It would have been kept idle for long time, and this maintenance might not be required at that point of time. To be honest, when they did a case study on flights, on aircraft maintenance, when they did aircraft maintenance study, it was reported that most of the faults happened in an aircraft just after the maintenance period. That is, after the engineers in that of the aircraft worked on the maintenance, that repairing everything, checking all the things, and checking the oil leakage. When they did all these things, it is only after that a huge amount of faults were found in that aircraft, when they ran after the maintenance periods. So this maintenance is sometimes not every time good. So that's where the concept of predictive maintenance, which every industry, mechanical industry, is moving towards. Let it be mainly in the aircraft industry, this predictive maintenance is going. Every sensor which is there in an aircraft, or let it be in your bikes. I'll take an example of bike, because in your bike you have an engine, the temperature, the sensors will calculate the temperature, the RPM, the torque of each part of the engine. It takes all this data, and it will predict what point this failure will happen of this machine, and what point it will happen. And based on this prediction, I will train a model. And after I train the model, now this model can predict when this failure of a machine will happen in the future, based on the riding conditions the bike or the aircraft goes through. So that's the new level of artificial intelligence and machine learning, which is going towards mechanical industries. Even industries like HVAC, your AC, your huge air conditions which are working in hospitals, all these are HVACs are working on predictive maintenance to predict when the next failure will happen, so that a right action can be taken before that, so that there will not be any problem. Because one small error in your machine, if it's a huge industry which is creating a lot of manufacturing products, or if it's a hospital where it's very necessity that every point of time there should be air conditioning, in these situations, if the machine fails, it's going to create a huge loss. Now machine learning and artificial intelligence, when it comes into picture there, it is going to save a lot of lives in hospital. The businessman who is doing the manufacturing industries, where the machines run a long period of time, right? So that's where this great applications of AI and machine learning is going towards mechanical field of industries. Similarly, we have in the e-commerce, retail, supply chain, your Zepto, your Amazon, Flipkart, all this works on some of the recommendation systems. Machine learning, there is a machine learning system which is going inside in it. Okay. So these are some of the examples. I would like to take one more video of saying where AI is currently used in agriculture field. Let this be another division. So let me play this video.
यार सेंसे
मैं इतने लोगों का फॉलो करता हूँ. I don't have any followers.
So we talked about groceries, the food we buy off the shelf. Of course, it's all cultivated and grown on farms. And if we head to India, 50% of the workforce are employed in agriculture, and a growing population, now 1.4 billion, are dependent on the crops produced. But traditional methods are now making way for new technology that promises to make farms more efficient, productive and profitable thanks to artificial intelligence. Archana Shukla reports.
For generations, Indian farms have been sown and tilled only with traditional know-how. But some, like Nitin Patil, are trying out something different. With sensor devices on his vineyard that check weather and soil health and uses artificial intelligence to figure out when to water the crops, add fertilizer and tackle pests. Nitin then receives a precise advisory on a mobile app.
This vineyard where we are now, it has no groundwater sources, and we are growing these vines with the water that we purchase from outside tankers. With the help of this AI data, we are now able to irrigate them only at the crucial stage, and that's helping us to save around 50% of the water that we used to give before.
Built in India's Silicon Valley, Bangalore by startup Fossil Agri-Tech, the service has led to a near 25% boost in productivity on crops like grapes and guavas. Informed decision-making is only one part of the solution to improve productivity, but weeding out inefficiencies in the existing age-old agricultural practices is also crucial. AI-powered robots offer a solution. This one is equipped with precision cameras that scan the ground in real time, programmed to avoid wasteful spraying.
The way spraying is done in India is on an acre level, and our mission is to boil that down into a plant level decision making. Just by spraying only on the plant, we are seeing a 56% savings.
Improved rural digital connectivity and government support for agri-tech startups has pushed farm innovations. But even now, just 2% cultivators use tech in farming.
We really need to enable the digital public infrastructure. And second is going to be public-private partnerships. India will always be resource constrained. We possibly are perhaps lowest in the yield level. We possibly are pretty much constrained on finance and insurance services for the farmers. And that's where the gap needs to be filled up with AI.
Data-driven agriculture promises profitability, but will need considerable time and investment to reach majority of India's farmers. Archana Shukla, BBC News, Bangalore.
Awesome, right? The application of AI in agriculture, for me, it's a great thing. I always wanted to work like something do in the agriculture field, and if you also have that interest that somewhere I want to start some be in the form of agriculture. If you have an idea of doing farming, great thing. You can apply this AI technologies into it, and understanding these concepts will be a great benefit for you in the future. Why agriculture is because look, almost 50% of our population is there in agriculture, which only makes almost 18% of our GDP. Okay, might be the figures are a little bit different, but this is the scenario right now in India. That's a very great loss, right? And if AI can be used in agriculture to increase the yield, it is going to benefit both the farmers and also the consumers. Like any both the prices of the agriculture will decrease. You would have heard about sometimes when tomatoes prices are very low, and at sometimes some months tomatoes prices are very increasing. Onions, this is bringing, and this problem has not been solved yet. But now scientists and a lot of engineers are working on using the models, artificial intelligence model and every other model to integrate everything. Let it comes to supply chain of agriculture, from the supply chain, from the base level, that is manufacturing of, that is agriculture products, to supply chain, integrating everything with AI so that this price will be stable always in the year. Right? It's because of supply demand issues. This onion price and tomato prices are low and high in certain point of time. Yes, there are many other factors also, but these supply demand issues really create a huge amount of issues. If AI could integrate in the supply chain of this problem can be solved. And you guys, in the future do AI models learn about it, I believe you come with a solution towards this main problem which India is facing right now in the agriculture industry. But look at what is the market and how is it market of AI and market opportunities and career in AI from 2024 to 2030. It's believed that the amount of investment is going to be a huge billions of amounts by 2030. And what are the top AI jobs in India? One is AI research scientist, data scientist, computer vision engineer, so AI product engineer. These are the most trending jobs right now, which every industry is required. And to be honest, you are the projects which you have chosen, 4 projects which you have chosen. If you're going to complete these projects and put it in your LinkedIn page that these projects have been complete with end-to-end complete solution, it's going to give a great opportunity. It's going to open for you towards industries. When you go sit in an interview, you will be in a position to explain these projects from end to end, complete end to end. And that's more than enough for a recruiter as a fresher they're looking into. You have done such good projects, and these 4 projects are unique and good. So I would like you to keep motivated till the end and finish the projects and put it in your LinkedIn so that you showcase in your resume regarding the projects you have done. Okay. And okay, so we go towards one of the basic concepts of machine learning. What is machine learning? Till now, we little bit learned about the basics of artificial intelligence, machine learning. It is what are these and where these applications are there. And might be it would have little bit at least motivated you or given an idea about where in my I can use what projects I can choose. Okay, but let us go in little depth about what is machine learning. Machine learning is a branch of AI focused on building computer systems that learn from data. So as I mentioned, it uses some of the statistical tools. It uses some of the statistical tools to create, and it learns from the data. It learns from data and then it tries to predict it. So if I keep machine learning is divided into 2 main concepts. One is supervised machine learning, another one is unsupervised. One is supervised machine learning, another one is unsupervised machine learning. What is supervised machine learning? So I said that machine learning is about it learns from the data. It learns from the data. Data can be in any format, right? Data can be in any format. It can be CSV format, it can be JSON format. Okay, but imagine I have a data, and imagine this data is about house price prediction. Okay, house price prediction. I live in a city, Bangalore, and in Bangalore, I want to find in different regions in Bangalore what is the prices of different houses, different areas. So in Bangalore, I have Kormangala, I have HSR layout, I have Kengeri, all this lot of places I have. I have their these are the location which I have. I have what is it? If I want to predict house price, what are the details I might have? I need to know the area of the house, how much square feet the area is. Then if there is metro available in that area, or if there is if there is a school or healthcare facility, if it's there, all these many factors will be there, and based on this, there is a price, right? There is price there. That is for every location I have different prices. Might be it be 3 lakh, 4 lakh, 5 lakh, 2 lakh, 1 lakh. Like this, prices also have. So if you see in this data, you can see that I have some columns which are known as independent columns, and I have a dependent column, that is price, which is known as target variable. It's known as target variable, right? So for every location or every different areas parameter, based on the area, location, every other parameters, I have different prices. So this is what you call the labeled data. You call a labeled data. And supervised machine learning, it runs with labeled data. You have labeled data in your supervised machine learning models. What is labeled data? There is a target variable and there are certain features for it. But when it comes to unsupervised machine learning, you do not have a labeled data, right? So I'll give you an example of what is unsupervised machine learning. And before that, we'll just go into supervised machine learning. Okay, so look at this another example of what is supervised learning. I have a data set. And I have some features which I mentioned it as independent features. It might be I want to try to classify fruits. This is my task. So to classify fruits, there will be certain features. The features of the fruits, like color, right? There will be texture. There will be shape. There might be pigments. If there is any pigments, color difference, everything. So there are many features. Based on many features, I have a target variable which says that based on these features, it is an apple. Or based on these another set of features, it is orange. Based on other set of features, it is a watermelon. This is already present in my data. I have a data set like this, which is present to me. Now what I do, I give this data set into my machine learning model. What is machine learning model? This model has many algorithms. There are different algorithms. Okay, which algorithms we need to use? I will explain you what type of algorithm and which situations we have to use. But it has some algorithms, and I put this data set, this labeled data set, into this algorithm, into this training data set. I train my model, and after I train my model, I try to predict it. What will I try to predict? After my machine learning model is being trained, I give a testing data. I'll give a picture of an apple, and I'll give a picture of an orange. And if my model is able to correctly identify whether it's an apple and whether it's an orange, then my algorithm has worked successfully. It is success. Right? That's a basic understanding of how machine learning works. In depth, there is little more. I'll be going what is the pipeline of it. But in overview, this is how supervised machine learning model is about. There is a target variable. What is unsupervised machine learning? In unsupervised machine learning, as I mentioned in the previous, you have features like color, you have texture, you might have shape, pigments. But I do not have a target variable. There is no target variable. There is no target variable that these features is equal to a brinjal or a capsicum or an onion. It is not there. There is no target variable. There is only these independent features which are there. And this, if I have a data set in this manner where it's not labeled, this is not labeled data, where there is no target variable. In that type of situations, we use unsupervised learning. And for unsupervised learning, you have different algorithms. That's why we are differentiating it. The reason is for each type of machine learning model. If it's supervised machine learning model, you have different type of algorithm. If you have unsupervised machine learning, you have a different type of algorithm. So that's why we need to differentiate in the starting itself, based on what your data set is about. So in unsupervised machine learning, now you'll ask me, how will the classification happen? How do I identify whether it's a blue or this one? So basically, if this raw data, look at this, it's an unlabeled data. There is a lot of, there is features of these brinjals, capsicum, there are only features of it. Now I train my model, and this model will do clustering. This algorithm, what it does is, it uses a method known as clustering. It will cluster, it will group up things. It will group items together. And after it groups up the items, these groups, see, it has classified into this one group. There's another group which has been classified, like these groups which are being classified based on these features. So this grouping takes place like this. And in this group, you will have all the common elements. In this case, what is that? Capsicum. This another cluster will have brinjals. Another will have onions. So this is where the concept of clustering comes. Clustering is a topic which comes in the unsupervised learning. And in unsupervised learning, you have different algorithms. One of the main used algorithms are k-means clustering and db-scan clustering. These are one of the main two techniques which are being applied in the case of unsupervised machine learning. This one, how the clustering happens. If you have time and interest, because in these projects we are not doing any clustering as of now, but if you have interest and time, you can learn about how the mathematics of k-means clustering works, how db-scan clustering works. But this session is not much enough to cover these topics at a point, but you can get an idea that clustering, when you're using unsupervised learning, we use k-means clustering and db-scan clustering algorithms. Okay, so I would like to give you another example to make you more clear about where unsupervised machine learning comes into place. Imagine I have there is a World Bank, right? There is World Bank, and this World Bank has got a huge amount of fund, and it has got an idea that it has to distribute the funds to different countries. It has to distribute the fund into different countries based on the developed countries, developing countries, and underdeveloped countries. So it wants to find these countries and group it in such a way and put the fund. So a lot of fund can be distributed to underdeveloped, little bit fund can be given to developed countries. For developing countries, a medium amount of fund can be given. And World Bank has a data of every country. It has a data of, there is country, for each country there is different features. What are the features to check? There is GDP, there is per capita income, whether how much investment is done to healthcare, how much investment is done to school and education. So all these features are there, and there are countries also. Now it is World Bank has to group the countries into developed, underdeveloped, and developing countries based on these features. And in this situation, you can use clustering techniques like k-means clustering or db-scan clustering. It can be used to cluster these countries, and finally, after clustering, the countries based on the features, it will be divided like this. There will be 1, 2, 3 countries. One will be developed, another developing, another underdeveloped countries. And based on this, now World Bank can put the funds to these countries, right? So this is one example, a real world example of where funds can be distributed. It can be used in customer classification. I imagine ICICI Bank. There is a bank which is there. It has the customer details of all that place. Now it wants to find whom to give credit card, how to give, which customers are spending a lot of money, and based on this, it needs to give advertisement. It will send in information. You'll be seeing your WhatsApp in your mobile. Each person, a salaried person, an employee, a student, will have a different type of messages which is coming in your phone. It's because these banks have the data of how your transaction is happening, and based on that, it will try to give you credits. It will give you credit score, every other thing, the classification. There are engineers working in bank. You can also be once you become a data analyst or a data scientist, you can also be working in banks and doing this. In banks have a huge role. Today, I met a person who is working as a fraudulent analyst in Goldman Sachs. So his story was a very great, what he does in the Goldman Sachs fraudulent analyst. So these roles are picking up. Every point, one role is coming in the form of in the data analyst and data scientist. Okay, so they all use these models, deep learning, every other model. It might be machine learning, simple model to get solutions and bring it up to the top management. Okay, so let me speak about what is the flow of a machine learning project, how a machine learning project will begin. First, I informed you even in your first session that it's one of the main important thing is you should know about Python. Python language is very important, and you should know one of the libraries, Pandas, right? Because Pandas is one of the library which is used to handle and manipulate data, right? So I would request you everyone, tomorrow there is a time, go through Pandas, this basic codes of Pandas, how to work on Pandas, and that would be great. When you do the project, you will be understanding how is it used, how to read a file. You need to import the data set which is in CSV format or a JSON format. You need to import it in your Python, right? For that you use Pandas, right? So once you import the data in your Python file, you get it in your Python language. Now this data might be not be very clean, right? There'll be some human errors in it. There'll be some missing values in it, or there might be duplicates in it. So it's very important that we process it. What does processing mean? We have to clean the data. First, we check it if there are some missing values. There in Pandas, there is certain codes, small, simple codes are there, which helps you to check if there are missing values. It helps you check if there are duplicates, and based on whether it's there, if there are any missing values, you can't keep that missing values and put it in your model, because model will get confused. These algorithms will not understand what is this missing value. Just wait a second. I'll just on the right. Yeah, clear. So the algorithm won't be able to understand the missing values in it. So you need to handle it initially, right? So that's where the cleaning process takes place. You fill the missing values using certain techniques. There are some techniques of using mean, mod, or and based on domain knowledge, you fill that columns which has missing values. But if it has any duplicates, what you do, you delete the duplicates. Because machine learning model algorithm, when it gets duplicated values, it will get confused. So you delete those duplicate values, right? So that's what data pre-processing comes into place. And after you do the cleaning of the data, then you go into visualization. You work on visualization, understanding what the data is about. Before we put it into a model, it's very important that what the data is talking about. Might be you have to analyze it in a singular manner, like how the columns are, how the features are, what is each feature saying? Is there any correlation between one feature and another feature, right? I'll give you one simple, there are many pre-processing text, but one simple example. Imagine I have two columns. I have two features which are there. And in the two features, it is about, take the example of the house price prediction. Okay. And I have area of the house and number of rooms are there. Now the area of the house is, if this 1200 square feet, it's almost like the number of rooms are 2 BHK. It may be 2 BHK. If it's 1800 square feet, it will be 3 BHK. So imagine this is the data. What happens is that when I try to find the correlation between these two columns, it is found that it's very highly correlated. These both columns are almost very related. That if there is this much area, this is fixed that it is almost there is 2 bedrooms. Now, in these conditions, I can remove one of these columns. I need not keep all the columns. There might be a lot of columns in my data set. It's not necessary that every column is required to be machine, because there are conditions like overfitting which happens in machine learning model. Okay, the machine learning model gets overfitted. If you feed it with a lot of data, similar data, it will not. What happens is that when you give a new data, it won't be able to predict the right result when you feed it with columns which are very highly correlated. So you might have to remove them. So that's another technique of data pre-processing. So to do that, we need to visualize the data. To visualize the data, we will be using matplotlib and Seaborn. We'll be using matplotlib and Seaborn library. will be using these two libraries. Okay, Matplotlib is the visualization tool where you can visualize each feature, whether it be univariate, only single column, or a double variate. So what is dual multivariate analysis? Based on two features, like it would be area and price. It would be area and price. Area and price of the house. As the area increases, the price is increasing. There's a linear what to say, there is a linearity seen in the between price and area. How will you find it? You can find it through making this visualization charts. And if you find it, if it's a linear type of relationship, you can use certain algorithms. So that's the importance of doing data visualization in terms of machine learning. Why it's very much required. And to be honest, 70% of your time and 70% of your energy will be going through these two techniques. One is in the data pre-processing. One is cleaning the data. In fact, when I was working in the industry, it took almost 3-4 days to just clean the data. But your projects are not that harsh, and this one we have given a very clean data. But in real world, when you're working in industrial level projects, it takes almost 3-4 days to even clean the data. And after cleaning the data, processing it, making the visualizations, understanding, all this takes a huge amount of time. Your machine learning part is a very small, this is there, no? This is a very small unit. It's always takes 30%, but very important part also. But this is a very important field. Almost 70% of your time you might spend in this field. Okay. So next is about choosing an appropriate technique. What is choosing an appropriate technique? I told you that there are this supervised machine learning model and there is unsupervised machine learning model. For each type of model, we use different techniques. Might be in supervised machine learning model, you will be in supervised machine learning model, you will be using certain algorithms like linear regression. You'll be using logistic regression. You'll be using decision tree, random forest in supervised. In unsupervised, you'll be using k-means clustering, DB scan. So which type of algorithm you need to use, that depends upon what type of data set is it. If it's a labeled data, then it's a supervised, then you can conclude that you can use these algorithms. If it's unsupervised, you can go with these algorithms. So choosing an appropriate technique comes under identifying what type of data set it is. Okay. But there's another thing which I missed out. In supervised machine learning, I'll be telling it, in supervised machine learning model, you have another division. One is classification type of problems and another one is regression type of problems. What is classification? What is regression? Why do we need to identify it? Why are we dividing it? Because based on these techniques, if there are these both type of techniques, there are different algorithms for these also. So it's very important to understand whether your data set is a classification type of problem or a regression type of problem. Let me make you understand. What is a regression type of problem? Regression type of problem, you will have your target variable. That is, in supervised machine learning, you have a target variable, right? If the target variable is continuous numerical, then it is a regression type of problem. If it is a classified type, like for example, you're doing your heart disease prediction. In your heart disease prediction, your target variable is what? Your target variable is if that person has a heart disease, yes or no, right? There are only two aspects: if the person has a heart disease or if he doesn't have a heart disease. So that type of, or in my predictive machine model, what is there? Whether the machine fails or it doesn't not fails, right? In these type of classification type of problem, we have classification. When it's a continuous numerical, what is continuous numerical? House prices. Your house price is a numerical data, which is continuous. Your height, your weight, all these things come under regression type of problem. So based on the classification, if you have a classification type of problem, you have certain models which is being used. One is logistic regression. logistic. If it's a classification type of problem, you use logistic regression algorithm, or you use decision tree algorithm, or random forest, and support vector classification model. These are some of the examples of in classification type of data set. These are the algorithms which can be used. But if it's a regression type of problem, the algorithms are linear regression, decision tree. You have decision tree. So decision tree is one thing which can be used both in classification and both in regression. Very good, very nice model to work upon. Then you have random forest. Random forest also works both in classification and regression. Then you have support vector regression, SVR. Okay. So these are some of the algorithms which you work in your project also. In your disease prediction algorithm, you will be using classification type of problem. It's a classification type of problem, right? Heart disease or Parkinson's disease, any disease which is there, it's a classification type of problem which you are working upon. And you'll be using logistic regression, decision tree, support vector classification, and which model is giving a very good performance, that model will be executing it in your final web page. Okay. So I hope you have understood what is in supervised machine, what is classification and what is regression. Okay. Okay. Then after choosing an appropriate technique, you understood how to choose your appropriate technique. Then the next step is to train your model. What is training? Your data set. Your data set. I'll go to the next page. Okay. Let us look into what is training a model. Training a model. What is training a model? You have a data set. Okay. Please concentrate, every student, please concentrate this very well. This basic thing you need to understand while doing any project, because if these basics are not right, then you won't be understanding the significance of doing the project. These basics, then further your efforts are more than enough to complete these projects, guys. Okay. So I have a training data set. I have a data set. This is my original data set, and I have a lot of rows and columns. Okay. These are your rows and these are my columns, right? Imagine I have 100 rows. I have 100 rows and I have like 5 to 6 columns. Okay, I have 100 rows and 6 columns in it. So when this is my original data set. Imagine this is the condition which I have. I have 100 rows and 6 columns. Now, in my algorithm, what I do is I will split this data into 2 parts. One is training data set and testing data set. I'll be dividing my data set into 2 parts. One is training data set, another one is testing data set. And how will I divide? I will give 80. Imagine 80 rows into the training data set. Imagine this is a supervised machine learning model. It's a supervised machine learning model, and I have a target variable also, right? I have a target variable also. So what I do, I give 100 in this 100 rows. I give 100 rows, 80 rows. I give it to my training data set, and 20 rows I give it to my testing data set, right? So what I do, I train my model with this 80 rows. This 80 rows has the target variable also. It has the target variable also in it, and I train the model. And after training the model, once the model, imagine I use a logistic regression. I use logistic regression and I train the model. And once I train the model, now I'm training you guys. After I train you, I want to check how good my model is. How will I do it? How will I do is this testing data set which is there. I will use this testing data set. This testing data set is also my original data. It has the target and it has the each feature which is there. So what I do is after training the model, I will give I'll give this some inputs, some the train model's features. I give it to it to predict. I'll predict. Once this model has been trained, I will try this model. This model will try to predict now the output. And whatever output has been predicted, this output, I compare it with my testing data set. Or you can call it as a validation. This is a better word. Validation data set. I compare my compare my predicted value, that is predicted output. Predicted output is the model predicted. What model is predicted? That output, I compare it with my original data set, validation data set. How much there is a difference, whether it is predicted well. So that prediction will be your evaluation. How to evaluate? You need to evaluate how good your model is. You can simply say, imagine you're doing a disease prediction, heart disease prediction model. And if your model is not working well, some patient with heart disease, he comes and the model predicts he doesn't have a heart disease. After 2 days, he'll be dead, right? Because your model has not predicted it very well. So you have to evaluate how good your model is performing. So that this evaluation is done by taking this difference of how the output and the original data set. Okay, that's where evaluation comes. And for different, if it's a regression type of problem, what is the regression I meant? If it's if the target is continuous variable, if it's a continuous thing, if it is continuous, then I use regression evaluation techniques like mean absolute error, mean square error, root mean square error, R square, and average R square. There is another average R square. Do not get tensed with these formulas. I know students, when they see the summation itself, they get, I can't study these things. Don't get worried about it. It's very simple. What is mean absolute error? It's very simple. This is your predicted value. Imagine this is your predicted value, and this is your original dataset value. What your machine learning predicted, and what is your original dataset, this one. That difference, you get mean absolute error. And if you take a square of it, why do you want to take a square of it? Might be this difference is a negative value. That's why they introduce square of it. And you take a square of it, take an average of it, then you get MSE. And if you take they realize that this MSE value is a very huge value because you're taking square of it. You took a root mean square, so that finally you get a positive value. And what is our aim? In regression, our aim is, in your evaluation, if you want to get a good model, our aim should be that this MAE, MSE, and RMSE, this has to be very low. If it's very low, then your model is performing very well. And if it's very high, you need to go back again to data preprocessing, use different algorithms and try it, test, trial, do the runnings, do different data preprocessing, and to get a better model. Understood? So that's how in regression type of problems, you try to evaluate how good your model is. And there's another term, R square. What is this R square? I want all of you to go to after this class, just research what is R square. And there is another term, average R square. Why these both terms are very much used in linear regression? You will get a value like, after doing your project in linear regression, you will get a value like 80% or 70%. What is this 70% and 80% in R square? It means, what is the significance of average R square and R square? The difference, if it's very huge, there is an issue. So I just want you guys to research about it. Okay. So this is about regression type of problems. But what comes in? See, these are all. Okay. Wait a second. This is regarding evaluating your model when it comes to classification type of problem, regression type of problem, evaluation. But what if it is a classification type of problem? Wait a second. Let me add a slide so that we can explain you. Okay. Okay. So in regression type of problem, you understood how to do the evaluation. But when it comes to classification problems, how do you evaluate your model? You trained, you did your training. How do you evaluate? What are the performance metrics which is used in classification type of problems? Let us look into it, because this is there one of part of your project also. How to evaluate a model? There are some techniques known as, one is accuracy, precision, recall, 4F1 score. And there is something known as confusion matrix. You know why this term confusion matrix is being given? Because this matrix is confusion. It's a confused matrix. Everyone gets confused out of it. That's why they named it as a confusion matrix itself. I hope I'll try my level best for you guys. I have almost like 1,000 or 997 students listening. I hope you don't get confused with this concept of confusion matrix. Okay, it's one of the evaluation techniques which is being used. So imagine a situation. If take the heart disease prediction model itself, and you have your model which is predicted, and original. This is your original in the validation data, and your model is predicted 1. If it's 1, then that person has a heart disease. If it is 0, he doesn't have a heart disease. If it's 1, heart disease, he has a heart disease, and another 0, 1. It is predicted like this. This is my model prediction. And I have another original in my data set, in my original data set from a medical industry which I've got. What the original it has predicted this also as in the original data set. What it is there, that the person has heart disease, this person also has a heart disease, this person doesn't have a heart disease, this person has a heart disease, this person doesn't have a heart disease, and this is my original data set. This is my model prediction. Now I need to check how good my model is. So there's a concept of confusion matrix which has been formed, and you have actual, you have predicted. I want all of you to concentrate on this. Do not look anywhere else. Just concentrate on this, because you won't get confused. Okay. And in predicted, the model prediction 0, 1, actual 1, 0. Okay. So how many situations are there in which actually in my data set, actually it is that person has a heart disease, and the predicted also is a heart disease? How many situations are there? There is actually 1, predicted also 1. There is 1. There is 2, only 2 situations. So in 2 situations, when actually there is heart disease, my model also has predicted it as a heart disease. Actually, that person doesn't have a heart disease, but my model has predicted it is a heart disease. How many situations I have? I have 1. I have 2. I have 2 situations here also, right? I have 2 situations. What about a situation where actually that person has a heart disease, but my machine has predicted that that person doesn't have a heart disease? Actually, he has a heart disease, but my model has predicted doesn't have a heart disease. How many situations I have like that? Let me look. Actually, there is a heart disease, that is 1, but predicted that it is not a heart disease. There is this situation 1, right? 1, 0, and there is originally that person has a heart disease, and it is predicted 2. There are 2 situations. It's 2 situations, and actually that person doesn't have he doesn't have a heart disease, and it is predicted also doesn't have a heart disease. How many situations are there like that? That is 0, 0. There is no situations like that. Okay. actually 0 and predicted as 1. That I have 1, 2. Yeah, so that this is how my data set is talking about. So in this situation, there are some terms which you need to remember. That is, if it's predicted this, actually it is 1, and if the predicted is also 1, we call it as true positive. And if it's actually 0 and it is predicted different, there is actually it is 0, but it is predicted 1, then you call it as false positive. It's falsely predicted, right? And in the same way here, it is actually 1, but it is predicted 0. It is false negative. And here it says true negative. These terms are very simple to understand. This positive comes from, if it's 1, if the predicted is 1, then it's positive. This is positive. If it's predicted is 0, then it's negative. And true and false comes from whether it's truly predicted. If it's truly predicted, then you call it as true positive and false positive. Now, in a medical data set, where it has to be, we have to try to predict whether the person has a heart disease or not. Which factor is very important? That is, in these four columns, rows which are there, like these boxes which are there, which of them is most important? I would say, in a medical data set, if a person actually has a heart disease, and if my model predicts that he doesn't have a heart disease, then there is a big failure in my model, right? My main aim has to be to reduce this false negative. This false negative has to be very low value. Because if the false negative is very high, then my model is very bad. That is, my model is, if the person is actually having a heart disease and my model is predicting he doesn't have, then it's going to end the life of a person, right? So in medical scenarios, your aim has to be to reduce. Medical scenarios, you have to reduce false negative, right? But there are different scenarios. There is another scenario. Like imagine spam classification. Spam classification. Now you all have got a internship letter from EduNet. Imagine you got it in your mails. Imagine Gmail or Outlook has put that certificate in the spam. If they've not put it in your inbox, what happens? You might not look into it. You will lose the opportunity, right? So what happened when an internship opportunity or an offer letter from Google, it goes into spam and not your inbox? That means that my Gmail machine learning model is not working very well. What is happening? Actually, it is not spam. Imagine if that mail was not spam. That is your offer letter. It is not a spam. So it is, I consider it as a 0. But my machine learning model has predicted it as a spam. It has predicted it as a spam model. At that point of time, if that happens, my machine learning, the value will be very high, right? False positive value very high. It's a very bad for my model. And my main aim has to be to reduce this false positive. In spam classification, my aim has to be to reduce false positive. So when you do your model, when you try to evaluate based on the scenarios, if it's a medical data set, you have to look into how much false negatives are there. If it's a very high, even if the accuracy, sometimes what happens, your accuracy might be very high. But in your medical data set, if your accuracy is very high, that's not only the factor which you need to look into. You need to also look into how much false negatives are being produced, how many false positives are being produced in case of spam classification. So there are terms precision and recall. So precision comes with the formula. With precision comes with the formula true positive divided by true positive plus false positive. It comes with this formula. So in your spam classification, your false positive has to be very less and your precision has to be very high. So when you have a data set of spam classification, spam email classification, when you evaluate a model, you have to be concentrating in the term of precision. In medical data set, which you'll be working on in a project, at that point of time, you will be looking into recall. Your recall percentage has to be very high. How will your recall be very high? Recall formula goes with true positive divided by true positive plus false negative. And your aim has to be to reduce the false negative and get a very good recall percentage. So when you, this is a theoretical concept. When you do the coding, right, it's a very two-step process. You will just, even the training the model, it is not a very complicated process. You just take the scikit, there is a library known as scikit-learn. You would have, in your orientation, you would have learned about scikit-learn, you would have done. You install the scikit-learn, you will take the model, whichever model you want, linear regression, logistic regression, decision tree. You will take the model, you will train the model. Training is also one-step process. And after training, you evaluate. That evaluation process, you should have this idea of all this. You need to know the theoretical concept, how good my model is. Otherwise, you'll be just implementing one fake model, okay, which is not going to be very useful for the industry. Right? So these basic concepts are very much important, this theoretical. If you have not understood, just go recap this video again or just research it. These are the concepts which you need to be very much looking when you're going through the project also. Okay, since we have very short amount of time, it's already 6:40. Let's move forward. Okay. I hope you have understood okay, there is another term known as F1 score. I would request all of you to check what is F1 score. If you understood accuracy, precision, recall, F1 score is another one small bit of it. Just go type it in Google, YouTube, or ChatGPT. What is F1 score in classification type of problem? This concept will be very useful when you're doing the project. Okay. Okay. So what are the for machine learning? What are the important libraries which you'll be installing and working on? One is NumPy. NumPy will be also used in your CNN when you're working on not in CNN, when you're working on images, right? We're using OpenCV. OpenCV, when you'll be using it, NumPy will be one of the greatest, because NumPy is basically used because it will handle arrays very well. It will handle arrays very well. Arrays can be handled in Python, but NumPy library makes it very simple, because I'll just give you a gist of it. When you're dealing with images are classified into RGB, right? There are 3 channels of images, and everything is in the form of matrices. Images are in the form of matrices, like this. So each thing is a channel now. Each matrix this might be R, this is G, this is B, and each of this has a different value ranging from 0 to 255. And based on these values only, you are getting the color image of it. So when you're dealing with images, you will be working on NumPy arrays. In this coming tomorrow in the time, also look into concepts of lists, arrays, dictionary, handling with NumPy. So these basic concepts, please do have a look and come when you do the project. Okay, it will be very useful. And then pandas, we'll be working with pandas to handle with data. And you have Matplotlib. I explained you Matplotlib is for visualization. Then you have scikit-learn for your machine learning. All your machine learning algorithms, decision tree, linear regression, logistic regression, everything is loaded into this. You just need to pip install this scikit-learn, and once it gets installed, take the model and train the model, and then evaluate the model. That's simple, the project is. But it's very important to know the theoretical background of it. So when you're doing the hands-on project, automatically go research on a daily basis. Keep put in efforts when you're learning something. From Monday, when the mentor is going to guide you to doing the project, you should also be very good or confident with the theoretical part. If you're not, just research it. Go ChatGPT, work now, because you're doing an internship right now, right? In internship, it's your work now to finish it. You will be learning it. You will be learning it through hands-on experience. And so when an interview comes up, you can explain it to the interviewer in a very detailed manner about what project you have done, what is the interviewer will ask a lot of theoretical questions. So you should be good with the theoretical part also. That you can take a research, you can do ChatGPT, you can learn on this basis. Okay. So these are some of in the scikit-learn, how you install the basics of installing scikit-learn into it. Okay. And yeah, I have already done the supervised learning. What is classification and what is numerical regression? I hope you have understood in the classification data. See, cat, dog, cat. Categorical labels are given. There's a numerical target in it. This one I have. If I have in my target label 100 110 like this, what does it mean? Is it a numerical? It comes under regression or it comes under classification? You should be very this one method that what type of thing it is. So based on your target variable, when you get like 1 0, so you should not be taking it as a regression. This is also classification data. You're classifying it. It's not a continuous numerical, right? So that's this one. One small example. I would like you guys to do it. A school wants to predict students' final exam scores based on their study hours, attendance, and assignment scores. What type of machine learning problem is this? Is it classification or regression? I think chat is disabled. Can't see the chat. Okay. Just look into. Okay. You can comment your answers. If a school wants to predict students' final exam scores based on the study hours, attendance, what type of machine learning problem is this? Is this a classification or regression? It's a score, right? Score is in form of regression type of problem. So it's a regression type of problem, right? So because scores are numerical variables which is continuous, it's a regression type of problem. A healthcare provider wants to develop a system to diagnose whether a patient has cancer or not based on symptoms and medical history. What type of machine learning problem is this? Is it a classification or a regression? Explain your reasoning. So whether the patient has a cancer or not, yes or no, yes or no. It's a classification type of problem, right? Very simple. So as I mentioned, why are we learning this? Whether regression and classification, the division is being done because for each type of model which you try to differentiate, you have different algorithms, right? For regression, you have linear regression, you have regularized regression, KNN, K nearest neighbors, decision tree, CART algorithm, support vector regression, ADA boost, gradient boost methods, random forest method, extra trees. You have very short period of time. So what I would suggest is your project is mainly based on classification type of problem. So in the meantime, you can go research about logistic regression. I would suggest you to go look into logistic regression and look into support vector classifier, learn about support vector classifier, decision tree classifier, and random forest methods. Just go through this, the theory behind it, because practically it's just going to implement it. Okay, but understanding the theory is very important of which algorithm you're trying to use. And these 3-4 algorithms you can have a look into for doing the problems. This ADA boost, all this comes under ensemble boosting methods, bagging methods. There are bagging, artificial neural network methods, ANN. So ANN comes under deep learning method. So that's what deep learning can also be used when you have a huge data set. You have a huge data set, and if you have a regression classification, you can use artificial neural network. Okay. So yes, what are the tools and technologies you'll be going through? You'll be going through all these Matplotlib, Pandas, TensorFlow. TensorFlow comes under deep learning, Keras for your image processing in CNN, sklearn for machine learning, NumPy for handling arrays, Seaborn for visualizations. So the Seaborn works under Matplotlib. So you need to install Matplotlib, then only the Seaborn also work. So it gives a better picturization of visualizations, everything. Okay. So you'll be working in Jupyter. You need to install Anaconda when you're doing the project. In Anaconda, you have this, you can launch your Jupyter. I would suggest to go with VS Code. If just go install VS Code and see that all extensions have been installed in your VS Code. Just research about it. Your VS Code, if it's a VS Code is very perfect, it's very easy to deploy the model. Even Jupyter model also will work very well. We'll be doing the project in Jupyter. You can use VS Code also. Okay. So that's it, guys. It's all about the basics of machine learning, which you have gone through. I would like to go through the questionnaire if you have any doubts, and I'll be just going through each and every concept which I have covered till now, so that you will be in a good position to understand. So there is another video about machine learning. It's given in 100 seconds. What I took almost 1 hour to teach you basics, this guy has correlated it in 100 seconds. So I hope you can try to understand what he's saying right now. Okay, little bit you can understand. Let us play this video now.
In a country where good education is a right, yet still a privilege for many, you've been one of the fortunate.
Machine learning. Teach a computer how to perform a task without explicitly programming it to perform said task. Instead, feed data into an algorithm to gradually improve outcomes with experience, similar to how organic life learns. The term was coined in 1959 by Arthur Samuel at IBM.
Wait a second.
This is Baba Now, and this is BB Now. Matlab Big Basket Now, delivering in 10 minutes.
Machine learning. Teach a computer how to perform a task without explicitly programming it to perform said task. Instead, feed data into an algorithm to gradually improve outcomes with experience, similar to how organic life learns. The term was coined in 1959 by Arthur Samuel at IBM, who was developing artificial intelligence that could play checkers. Half a century later, and predictive models are embedded in many of the products we use every day, which perform two fundamental jobs. One is to classify data, like is there another car on the road, or does this patient have cancer? The other is to make predictions about future outcomes, like will the stock go up, or which YouTube video do you want to watch next? The first step in the process is to acquire and clean up data. Lots and lots of data. The better the data represents the problem, the better the results. Garbage in, garbage out. The data needs to have some kind of signal to be valuable to the algorithm for making predictions.
Just give me a second.
And data scientists perform a job called feature engineering to transform raw data into features that better represent the underlying problem. The next step is to separate the data into a training set and testing set. The training data is fed into an algorithm to build a model. Then the testing data is used to validate the accuracy or error of the model. The next step is to choose an algorithm.
I think there is a lag, guys, in the video. We'll again play it from start. There is some lag issues which is happening. Just play it again now. Okay.
Machine learning. Teach a computer how to perform a task without explicitly programming it to perform said task. Instead, feed data into an algorithm to gradually improve outcomes with experience, similar to how organic life learns. The term was coined in 1959 by Arthur Samuel at IBM, who was developing artificial intelligence that could play checkers. Half a century later, and predictive models are embedded in many of the products we use every day, which perform two fundamental jobs. One is to classify data, like is there another car on the road, or does this patient have cancer? The other is to make predictions about future outcomes, like will the stock go up, or which YouTube video do you want to watch next? The first step in the process is to acquire and clean up data. Lots and lots of data. The better the data represents the problem, the better the results. Garbage in, garbage out. The data needs to have some kind of signal to be valuable to the algorithm for making predictions. And data scientists perform a job called feature engineering to transform raw data into features that better represent the underlying problem. The next step is to separate the data into a training set and testing set. The training data is fed into an algorithm to build a model. Then the testing data is used to validate the accuracy or error of the model. The next step is to choose an algorithm, which might be a simple statistical model like linear or logistic regression, or a decision tree that assigns different weights to features in the data. Or you might get fancy with a convolutional neural network, which is an algorithm that also assigns weights to features, but also takes the input data and creates creates additional features automatically, and that's extremely useful for datasets that contain things like images or natural language, where manual feature engineering is virtually impossible. Every one of these algorithms learns to get better by comparing its predictions to an error function. If it's a classification problem, like is this animal a cat or a dog, the error function might be accuracy. If it's a regression problem, like how much will a loaf of bread cost next year, then it might be mean absolute error. Python is the language of choice among data scientists, but R and Julia are also popular options, and there are many supporting frameworks out there to make the process approachable. The end result of the machine learning process is a model, which is just a file that takes some input data in the same shape that it was trained on, then spits out a prediction that tries to minimize the error that it was optimized for. Can then be embedded on an actual device or deployed to the cloud to build a real-world product. This has been machine learning in 100 seconds. Like and subscribe if you want to see more short videos like this, and leave a comment if you want to see more machine learning content on this channel. Thanks for watching, and I will see you in the next one.
I hope you got an idea of what he is trying to say. He was very fast, really, but he wanted to complete in 100 seconds what machine learning is about. I hope you have understood few concepts of the depth of what is machine learning, and you have an idea of what now to research about, right? What are the things you need to learn now? I would like to go through the chat, or if you have any doubts or such, the questions and answers. And let me just move into. Suppose we have a data set where target variable predicts that a person has a 50% likelihood of heart disease. Would this problem be classified as a regression classification or something? So suppose we have a data set where target variable predicts that a person has a 52% likelihood of a heart failure. So you are saying that the target variable is showing it in the form of 52% likelihood of heart failure. So what are you trying? The target variable has to be in the form of whether the person has or not have. I didn't get the idea of what is 52% likelihood of having. Data has to be, when you get the data, it has to be properly classified. Whether might be, it will be like in the stages, like if it's in a high stage or a low stage. So in that situation, if it's classified like he's in the high stage, 1, or if 1 is the highest and 4 is the lowest stage of having a heart disease, at that point of time, you can, that can also come under the classification type of problem. So it's better you divide the data set based on the percentage. You make another column of telling that from this percentage to this percentage, classify it as 1. If it's this percentage to this, classify it as 2. So you make a separate column and then consider it as a classification type of problem. That's how you can do it, work on. Because the regression won't work there. Not a very good technique to go with the regression type of, because you're trying to predict if a person has a heart disease or not. Okay. Install for image generation using stable diffusion and Confer UI project. So you'll be installing Pillow library, and in the stable diffusion you'll be working on with Pillow library. Confer UI is it's just a user interface to create this. When you're doing generative AI, it has made that user interface. It makes it more easy for you to create the images. Your mentor will be guiding you in very well mannered of how. How it works. Okay, so you also do a research about what is diffusion. So you go have a look into what is diffusion, how diffusion model works. So basically what it does is that it combines all the noises to create a perfect images. So that's what a diffusion model tries to do. You also go have a look into that. Please provide recording videos in S. Recording videos will be present in the LMS. By tomorrow it will be present. AI healthcare, and can you tell me the concepts I should learn? In AI healthcare assistant, you will be working on NLP. You will be working on a little bit concepts of natural language processing. Okay, NLP will be working. You'll be working on which LLM model we have to use. We'll be using certain LLM models to create suggestions, to create the answers. So you'll be using BERT models also in that. So NLP is very important. You need to understand what is tokenization. Have a this about what is tokenization, what is stemming. See, these concepts will be bag of words, stop words, in the NLP. So these concepts will be very much necessary when you want to do the AI healthcare assistant. Okay. I can't see my previous sessions. So previous sessions, guys, yesterday's recordings, today's recording, everything will be put up today. Next class, guys, based on your project it is. The next week, which project you have chosen, based on that the calendar has already been given to you. So if you have chosen project 1, there are specific days on the next week it will be working on. So you should attend it on those days. What to learn for chatbot project, I've already told you. Chatbot, for chatbot also you'll be using VS Code. We'll be using VS Code as an interface to do the complete and there'll be Streamlit for integrating. Finally, after doing it and putting it in your form of web page, we'll have your final model in the web page. We'll be using Streamlit. Streamlit is another very simple library. Very simple library. You can learn it while doing the project itself. Do not take a headache about Streamlit. What I need you to do in this coming 2 days is learn properly about basics of Python. Be good with basics of Python so that when you do the project, you'll understand why certain things are there like that. Okay. List, dictionary, pandas, numpy, be good with these basics so that when you have good with these basics too, even ChatGPT can help you a lot in doing the project. Like it gives you a lot of answers you can understand at that point. But do be very good with basic foundation. Do not go with higher things. All our we are there for you to guide you how to do the project. Okay. But when we're doing the project, you should not be asking, sir, why that list is there, why arrays are there. Those basic questions, it will take a lot of time. It will be very tough for us to manage it. So be good with the basics. What to learn for the class? See, this is not a class, right? This is part of your internship. We are doing an internship, and this is one basic introduction for you to understand what is AI, what are you going to do it. So it's your duty now to go and research about it. We are not spoon feeding anything. This is not a spoon feeding module. This is not a class. This is not a lecture. This is only one lecture you have. It's further you will be doing the project. So you have to work. When you guys, I'm telling you, when you work, when you try to research about it, you will learn it in a very better manner. And there are a lot of resources available. This internship, you have to work 70%. 30% we will be guiding you how to finish the project. And if you have any doubts while doing the project. Understood? So for potato disease, what are the topics that need to be learned for potato disease project? Potato disease project is about images. So you will be working on OpenCV library and CNN, convolutional neural network, which comes under deep learning, right? You'll be using PyTorch and TensorFlow in that point of time. So what are you trying to do is very simple words. What you're trying to do is you have a data set of different plants, leaves. The training module, the data set is there, which a lot of pictures of leaves of disease, and it has been classified well whether the potatoes has disease or not. And you train the model. Using CNN algorithm, you train the model learns about it, learns each images, how is it and what, and then it classifies it. And after training the model, then you give an image from your testing data, and you will check whether it's predicting it correct or what. If it's predicting good, then good model, then you will be using that model, and then you will be giving multiple images from different resources, and it will give you the result. That's what you're trying to do. So you'll be working with OpenCV. Why OpenCV? Because when you give these images, you need to rotate it, resize it, and give it in a different manners. You should not be giving directly the images which is being given, because sometimes the machine learning model, the farmer takes the image in a different orientation. Machine learning model has to understand it, right? So you will give it in a different orientations. Getting it? So you should be working on OpenCV also. OpenCV, another very simple. These codes of resizing, clipping, and rotating, it's all very simple codes which are there. Guides will be guiding you what you need to do with each project. So when he or she is guiding you, what you need to do is go back to home and see the theoretical part of it. Codes are very simple. 2-3 lines, the codes will finish. What your work is to do is to have again the theoretical. What is the theoretical? Go watch some videos and learn about it, so that when you finish your project, you'll be good with practical sense, and at the same time you'll be good with the theoretical sense. Okay. So can we use Google Colab? I would suggest no, don't use Google Colab because these projects are very quite simple. It will handle your laptops will handle it very well. And Google Colab, you cannot use it for deploying your model. Deployment, that is final deployment, you can't do with Google Colab. Do it in VS Code or Jupyter Notebook. Okay. Will we get this PPT? Yes, you will be getting this PPT. Can we get the PPT? Yesterday's PPT. Yesterday's and today's PPT are both same. Sir, I missed yesterday's session. Where can I watch it? You did not watch it yesterday's. Today, if you watched, it's more than enough. Okay. So, what to learn for chatbot project? I've already answered this. Tell me about sigmoid function. Good. You have you asked about sigmoid function. See, sigmoid function is kind of an activation function which is used in a neural network. Both it's there. It's when it comes to classification type of problems. Also, you want when you're using sigmoid function, it classifies based on the values. It classifies into two categories. So that's where the sigmoid function comes into place. In short, that is how we can explain you. If you are interested to learn more, you can type it, and it's mainly used in both the situation. When it comes to deep learning, also you'll be using it in the classification type of problems. It'll be ranging from 0.5 to 1. Okay. So basics. What should I learn? I've already answered, guys. Okay. Wait a second. Am I getting a lot of questions? Example of World Bank. Is it supervised or unsupervised? Example of World Bank is unsupervised machine learning because it doesn't have a target variable. You don't have a target variable whether it's a what country? That developed country or a developing country. You do not have that. For AI health assistance, what topics we require? NLP, natural learning language processing. You have to have the concepts of NLP, tokenization. In NLP, there are some concepts like tokenization, bag of words, stop words. So have an idea about it. Okay. What we have to learn for prediction of disease. So prediction of disease outbreak project comes under classification type of problem. In machine learning, you'll be using scikit-learn library. It's a classification type of problem. You'll be using models of logistic regression, decision tree, and random forest and support vector classification. These 4 models will be used. It is a classification. It comes under supervised machine learning model. Okay. On which platform we are going to deploy the project? You'll be using Streamlit library. Okay. Can you explain difference of CNN and diffusion models? This time is very low is to explain. It's a very huge topic of convolutional neural networks and diffusion models. Maybe in the next sessions when we have, we'll be explaining it. So can we select any project like P1, P2, P3 project? Can we choose any project based on our preference? You can choose, you're choosing the project. It's all based on your preference. Okay. Your motivation to do what. So at time of next scheduled session, I have my college. Can I get you will get the recordings of every sessions, guys. Okay. I think most of the doubts are cleared. Okay. I just, so this is all about the session. It's already 7:05, and I guess you guys have got an idea. The main idea of this session was to give a motivation for you guys to learn further, to work harder. Okay, you have got the basics of what is machine learning, deep learning, whatever project you have chosen about, and whatever I've told you, go research about it. You have Sunday, tomorrow, the whole day is there. Research, read, use ChatGPT, get to know what these things are. Type the project and get to know what this is about. Learn, research. I'll tell you, you guys will learn in the most best manner than listening to lectures like this. Research on your own, complete the project, keep the same enthusiasm, finish the project, and I want every one of you who has put it in on LinkedIn to show that the project has been completed and you have got the certificate. Okay, so let's wind up the session, guys. I had a wonderful time with you. Saturday evening, you guys are present for 2 hours. Thank you for that. And let's wind up the session. Hope you have enjoyed it. Hope you have learned something. Put your efforts, guys. You guys will make it. Thank you.